25. 25 is 5 square. It is the square of a prime number. Can I write like this? Actually, ideally, you should not write. Why? Because HCF of 5 comma 5, it is 5. It is not 1. If I write like this, what probably can happen is some wrong answer options can be eliminated. If you write like this, you can probably tell which answer options are wrong. You can probably tell which answer options are wrong. For example, the answer for this question is actually 3 power 20 power 4 divided by 25. This is nothing but 1. This is nothing but 1. Suppose if I do it with 5. If unknowingly if you do it, you can still say which answer options are not possible. 3 power 4 power 20 by 5, which is 1. So answer when divided by 5, it should give a remainder 1. It should give a remainder 1. If there are options like 3, 7, 13 and none of this, if you happen to write like this, mathematically it is incorrect. Even if you happen to write like this in hurry, it can still give you some push to say that these answers can be wrong. Even a wrong methodology can actually tell you which are not possible. Answer when divided by 5, it should give a remainder 1. All the 3 are not possible. All the 3 are not possible. All the 3 are not possible. In one of the previous year CAT examination question, I did like this. The question also I just made use of some intelligence and I eliminated all incorrect answer options. 25. Options are like this. These 7. Next it is 10. Next it is 9. Next it is 13. 7, 10, 9, 13. One is by using quotient function I can do it. So 25. Even if in hurry you write 5 into 5. 4 divided by 5 minus 1. 6 divided by 5 plus 1. Perfectly divisible. Answer should be perfectly divisible. This cannot be, this cannot be, this cannot be. So the only option possibility is 10. Suppose if there is an option 20, you can only eliminate 3 incorrect answer options. Ideally, you should not do like this. Even in hurry, if you do like this, there are still chances. Sometimes when you are playing cricket, unknowingly, you don't intend to play the shot, but it reached 4 runs. Sometimes when you do an incorrect methodology, still it gives you a ray of hope that these all are not possible. These all are not possible. All are not possible. Like a Bumrah hitting a 50 runs, like somebody, Ishant Sharma hitting a sixer, like a Venkatapati Raju coming out with a century. Sometimes miracles do happen. So these one of the miracles where the methodology is wrong, but it can give some incorrect answer options. Some incorrect answer options. These will only eliminate incorrect answer options. Only eliminate incorrect answer options. Sir, why it is still giving you an incorrect answer options? Why? Because 25b plus 1 we got. 25 is a multiple of 5. 25 is a multiple of 5. Here you will get 25 into something plus 25. 5 is a factor of 25. When you are writing 25 into something, there is 5 into something. There is 5 into something. You can be little smart. Suppose if the options are like this, 41, 43, 42. If more than one answer options are not like this, then probably this method should not be used. Should not be used. For example, if the options are 41, 43, 42, 34. 41, 43, 42, 34. In hurry you did like this. Still it will eliminate incorrect answer options. 6 power 84 divided by 7. 7 ones are 7 minus 1. Minus 1 power an even number. It is nothing but 1. Answer when divided by 7, it should give a remainder 1. Answer when divided by 7, it gives a remainder 1. What we'll do is, we will write one more option or options which might be a doubt, a student might get it. So see here, and when divided by 7, it gives a remainder 1. 7 into 5 plus 1, not possible. 7 into 6, not possible. 7 into 5 minus 1, it is not possible. Even though you wrote it as a product of non-coprimes, 3 answer options you are able to eliminate. 3 answer options you are able to eliminate it. 3 answer options you are able to eliminate. I hope the idea it is clear. Writing the number as a product of non-coprimes can help us in telling this answer is incorrect. It will never definitely say that this is the only answer. Eliminating incorrect answer options, you can write it as a product of non-coprimes. 18 is 2 into 9. Just 5 divided by 2, remainder 1. Answer when divided by 2, it should give a remainder 1. Immediately, when you get a remainder for one of the factors, check the answer options. Check the answer options. Immediately, if one of the factors you got the answer. Answer when divided by 2, it gives a remainder 1. Answer when it is divided by 2, it gives a remainder 1. Anything which is perfectly divisible by 2, that is an incorrect answer options. Morning we solved this question, we got the answer 43. We got the answer 43. I hope the idea it is clear. You can actually be little smart and you can get the answer very orally. 25, even if you write it as product of 2 coprimes, 21 divided by 5, 5 fours are 20. Answer when divided by 5, it should be of the form 1. Any answer option which is gives a remainder 2, gives a remainder 3, gives a remainder 4 or 5, these are all wrong answer options. If fortunately if you got any of these numbers of this form, then probably it cannot be an incorrect answer option. Again, I am writing. Please do not get confused. If the denominator it is a composite number, write the number as a product of coprimes. Coprimes, if you write it, you will get the right answer. In case in hurry, if you write it as product of non-coprimes, you can eliminate few incorrect answer option. Second is not an ideal method because there could be 3 answer options which matches that form. There could be 2 answer options. There could be 1 answer option which does not satisfy. Second is like that acid test which we do to check whether the rice has got boiled or not. Second one, first do this for 10 seconds. If you are able to eliminate 3, then tick mark 1. If you are able to eliminate 1 or 2, then ignore that method, go to this method. I hope the idea it is clear. Next one. Crystal clear clarity in any of the concepts that we are discussing. Not a single doubt you will get in any of these classes. Now, 128 power 100 divided by 123. 153 is 17 into 9. So these are nothing but remainder 128 power 100 divided by 17. 17 sevens are 119. Remainder it is 9. 9 power 100 divided by 17. 17 it is nothing but 16. 6 are 96 into 9 power 4 into 9 power 4. I am using Fermat's theorem. Chinese remainder theorem, you will solve it fast if you know Fermat's theorem. This one. 81 by 17. 17 5s are 85. Minus 4 into minus 4. It is 16. So answer when divided by 17, it is nothing but 16. Similarly, 128 power 100 divided by 9. 128 power 100 divided by 9. 9 14s are 126. Remainder is 2 power 100 divided by 9. 2 power 100 divided by 9. 2 cube power 33. 8 by 9 is minus 1 into 2 power 1 by 9. 8 by 9 is minus 1 minus 2. So positive remainder it is 7. Positive remainder it is 7. Already we did this question I think. 9b plus 7 and 17a plus 16. Answer 17a plus 16. Till now, whatever problems that we discussed are the basic foundation problems. Basic foundation problems. Another important key point. Another important key point which everybody should know who are preparing for competitive examinations where number system is a part of it. Chinese remainder theorem. Chinese remainder theorem is used to find the reminders. Here, numerator and denominator. Here, numerator and denominator may or may not be coprime. Here, numerator and denominator may or may not be coprime. Here, numerator and denominator may or may not be coprime. May or may not be coprime. Now if you see, in Chinese remainder theorem is not only used when the numerator and denominator are coprime, even if they are not coprime, we can use this logic. That is exactly the reason this fifth question is mentioned. Question is 1, 2, 3, 4, 5 and so on up to 40. 1, 2, 3, 4, 5 and so on up to 40, which is an even number, divided by 36. Divided by 36. These is an even number, these is an even number. HCF of two even numbers, it can never be 1. But still you can use Chinese remainder theorem. 36 is nothing but 4 into 9. 36 is nothing but 4 into 9. Make the number as a product of two factors. What is the divisibility rule of 4? Last two digits should be divisible by 4. 40 is divisible by 4. Perfectly divisible, so it is 4a. It is 4a. So the divisibility rule of 4 is last two digits should be divisible by 4. Last two digits should be divisible by 4. 9 is sum of the digits should be divisible by sum of the digits. Sum of the digits should be divisible by 9. Sum of the digits should be divisible by 9. Sum of the digits means 1 plus 2 plus 3 and so on up to 40, which is n into n plus 1 by 2, which is 820. 8 plus 2, 10. So remainder it is nothing but 1. Remainder it is nothing but 1. 9b plus 1. 9b plus 1. Now, when I was taking this class some years before in IIT Delhi, one student asked me a question. Anil sir, here 1, 2, 3, 4. Sometimes you are taking single digits. 10, 20 you are taking two digits. Now see here sir. Digital sum of 1 plus 2 plus 3 plus 4 plus 5 are 123 plus 45 are 12 plus 345 are 123 plus 45. In whatever order you take, digital sum does not change. Digital sum does not change in whatever order you take. Whatever order you take, the digital sum does not change. Check it out. 5 plus 4, 9, 12, 14, 15. 15 digital sum is 6. 15 digital sum is 6. 123 plus 45, 168. 168 digital sum is 6. 345 plus 12, 357. Again the digital sum is 6. 120, these already taken. These already taken. So it really does not matter whether you are adding single digits first, then when you are adding two digits, it really does not matter. In whatever the order that you add, sum of the digits will not, value will not seen. There are two important learnings from this question. Chinese remainder theorem is used when the numerator and denominator may or may not be co-prime to each other. This number is an even number, this is an even number. Still we can use that logic. 36 is 4 into 9. Divisibility rule of 4 is last two digits should be divisible by 4. 40 is perfectly divisible by 4. 4a. 9 is sum of the digits should be divisible. Sum of the digits is 1 plus 2 plus 3 and so on up to 40. Sum of the first n natural numbers is n into n plus 1 by 2. n into n plus 1 by 2. 40 into 41 by 2, which is 820. 820 is 8 plus 2, 10. So answer is nothing but when divided by 9, it is of the form remainder 1. Perfectly divisible. So 4a equivalent to 9b plus 1, 8b plus b plus 1. Divisible by 4, divisible by 4. B minimum value, it is 3. 9 3s are 27 plus 1. Answer for this question is 28. Answer sixth one. This is a question. The best thing about this question is write this question like this. I'll tell you why am I writing like this. 1, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. In fact, you don't need to write all this. 4, 5, 6. 1, 2, 3, 4, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Till 8, right? It is divided by 36. You will observe a beautiful pattern in this question. Divided by 36. 36 is a composite number. It is a product of two co-primes. 36 is 4 into 9. 78 divided by 4. 4 19s are 76. Remainder 2. Answer when divided by 4, it gives a remainder 2. Answer when divided by 4, it gives a remainder 2. Answer when divided by 4, it gives a remainder 2. Next I should do, what is the divisibility rule of 4? Last two digits should be divisible by 4. What do you mean by 9? 9 is sum of the digits should be divisible by 9. In the divisibility rule, I will discuss in detail why these concepts came into picture. Sum of the digit, just now we discussed. You take 2 digits, 3 digits, 4 digits, 5 digits, 6 digits, 7 digits, 8 digits. Answer does not change. So the digital sum is, first it is 1. What is 1 plus 2? 3. 1 plus 2 plus 3? 6. Here it is increased by 2. Here it is increased by 3. Here it is increased by 4. Increased by 5. Increased by 6. Increased by 7. Increased by 8. Increased by 8. These are nothing but plus 4. It is ending with 4, add 4. It is ending with 5, add 5. Ending with 6, add 6. Ending with 7 and ending with 8. 1, 3, 6, 10, 15, 21, 28 and 36. I hope the idea it is clear. This cancel. Sum of the digits 9. Cancel. 28 digital sum is 1. 10 digital sum is 1. Here also it is 1. Even if you add it, 36 plus 28, 64. 64 plus 21, 85. 100, 110, 116, 119, 120. 120 digital sum is 3. 4a plus 2 equivalent to 9b plus 3. So 4a equivalent to 9b plus 1. So 4a equivalent to 8b plus b plus 1. 8b plus b plus 1. These divisible by 4. These divisible by 4. B plus 1 should be divisible by 4. B minimum should be 3. B plus 1 it is 4. B minimum it is 3. 27 plus 3. 27 plus 3. Answer is nothing but 27 plus 3. Answer is nothing but 30. A very, very high quality cat level question. Here you can play by using answer option. Answer when divided by 4, it gives a remainder 2. Answer when divided by 9, it gives a remainder 3. 30 it is 4 into 7 plus 2. 30 is 9 into 3 plus 3. I hope the idea it is clear. 36 is 4 into 9. Divisibility rule of 4 is last 2 digits should be divisible by 4. Divisibility rule of 9 is sum of the digits should be divisible. 1 plus 3. 1 plus 2 it is 3. 1 plus 2 plus 3 it is 6. 10, 15, 21, 28 and 36. I hope the idea it is clear. Next question. This is a beautiful question, sir. Please put a star mark on this question. Cat level question. Cat level question. Cat level question. In prime numbers, we will discuss in detail this concept. This is nothing but remainder 1. 6, 6, 6, 6 and so on up to 2002 times and so on up to 2002 times divided by 2002 divided by 2002. 6, 6, 6, 6, 6 written 2002 times divided by 2002. 2002 is nothing but 2 into 1001. 2002 it is a composite number. Write down the number as a product of coprimes. 2002 is 2 into 1001. 2 it is an even number. Last digit will be 6. So perfectly divisible. Perfectly divisible. So it is 2a. Please write down this. Divisibility rule for. Divisibility rule. I will discuss in detail. I will discuss in detail in prime numbers 7, 11, 13, 77, 91, 143 and 1001. Please write down this. We will discuss comprehensively how to find out the divisibility rule for any prime number in detail. 2002 is 2 into 1002 times, 2 into 1001. 2 anyway, it is an even number. So perfectly divisible 2a. We are determining divisibility rule for 1001. Divisibility rule for 1001. See here, 77 is nothing but 7 into 11. This is a composite number. It can be written as a product of prime numbers. 91 it is a composite number which can be written as a product of two prime numbers, 7 into 13. 143 it is a composite number which can be written as 11 into 13. 1001 is a composite number which can be written as 7 into 11 into 13. So the divisibility rule for this number, it is the same as this number, total 7 numbers divisibility rule. Total 7 numbers divisibility rule, it is same. In the class, we will also discuss, in our paid batch, we will discuss the divisibility rule for any prime number. Generally, in the textbooks, they will select only some numbers. Actually, you can develop your own divisibility rule for any prime number. Divisibility rule for any prime number, that is popularly known as theory of osculation. Theory of osculation. Theory of osculation. Very, very interesting theory. We will find the divisibility rule of 41, which you will not find it in any of the local textbooks. Divisibility rule of 43. Divisibility rule of 73. Divisibility rule for 137. Divisibility rule for 137. Divisibility rule for any prime number is derived from the concept theory of osculation. Theory of osculation. Theory of osculation. Now we will write one concept. First write down, sir. divisibility rule for 7, 11, 13. Divisibility rule for 7, 11, 13. Divisibility rule for 7, 11, 13. Right? Now see here. What is the Fermat's theorem we discussed? Fermat's theorem states, morning session we discussed Fermat's theorem. What is the Fermat's theorem? Fermat's theorem states, reminder 1, a power p minus 1, when divided by p, it is 1. When a and p are coprime, and p is a prime number, Fermat's theorem. In case if you have not seen the previous 3 sessions, I would request you to watch it. Then you will understand the entire topic. One important subtopic in number system, reminders, I am trying to complete in detail comprehensively. Fermat's theorem states, a power p minus 1, when divided by p it is 1. A comma p are coprime, p is a prime number. For example, reminder 1, 10 power 6 divided by 7 it is 1, because 10 and 7 are coprime. If I call 10 power 6 as 10 cube into 10 cube, if I call 10 power 6 as 10 cube into 10 cube, let me see what is happening for 10 power 3 by 7. 10 power 3 by 7. 10 power 6 is nothing but x square. If x square it is 1, x will be plus 1 or minus 1. Let us see. 7 ones are 7, 3 reminder. 27, 7 fours are 28. It is nothing but minus 1. I hope the idea it is clear. 10 power 6 is 10 cube whole square. X square it is 1. So x value will be either you will get plus 1 or minus 1. We got minus 1. See, these are all very, very interesting concepts, sir. Suppose if I take 10 power 10 divided by 11, it is 1. 10 power 10. So x power 5, suppose if I take, for example, if I take 10 cube divided by 11. 11 ones are 11. Minus 1 cube is minus 1. I hope it is clear, right? Next one. Suppose if I take 10 power, I want to correlate it. 10 power 12 by 13, it is 1. Let me see what will happen. 10 cube by 13. 13 ones are 13. Minus 3. Minus 27. 13 into minus 2 is minus 26. Remainder is minus 1. 10 cube divided by 7 is minus 1. 10 cube divided by 11 is minus 1. 10 cube divided by 13 is minus 1. So 10 cube divided by 7, 11, 13. Answer is nothing but minus 1. Answer is nothing but minus 1. Concept is 10 power 3 divided by 7 it is 1, 11 it is 1, 13 it is 1, minus 1, sorry, it is minus 1, not plus 1. 7 into 11 into 13, it is 1001. 10 cube divided by 1001, it is minus 1. Directly you can write 1000 by 1001 is minus 1. But I want to explain you the factors of 1001 logic also. So if I take, for example, 6 is written 6 times. 6 is written 6 times divided by 1001. These are nothing but 666 into 10 cube plus 666 divided by 1001. Divided by 1001. So the answer is nothing but these minus 1 minus 666 plus 666. Minus 666 plus 666. It is 0. Two conclusions. Please write down these two conclusions. Any three-digit number written even number of times. Any 3-digit number written even number of times. Any 3-digit number written even number of times. It is always divisible by 1001. Not only by 1001, but also the factors of 1001. Why it is happening? Proof. Why it is happening? Proof. Reminder 1. 1, 2, 3, 1, 2, 3. Divided by 1001. These are nothing but remainder of 123 into 10 power 3 plus 123 divided by 1001. These minus 1, it is 0. It is 0. Suppose even number of times, 2 times only we wrote. Let me write 4 times. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 divided by 1001. Divided by 1001. See here. This can be written as 123 into 10 power 9. 123 into 10 power 6. 123 into 10 power 3 plus 123 divided by 1001. These minus 1, minus 1 square plus 1, minus 1 cube minus 1. So all of them will get cancelled. All of them will get cancelled. It is just not in solving the question. We will discuss the concept hidden in this question in detail. Any 3-digit number, written even number of times, any 3-digit number written even number of times, it is always divisible by 1001. Any 3-digit number written even number of times, it is always divisible by 1001. I hope this concept is clear. Suppose question is 112, 112, 112, 113 divided by 1001. 112, 112, 113 divided by 1001. Take a group of 3 digits. Take a group of 3 digits. Plus minus, plus minus. These cancel. 113 minus 112. 113 minus 112. Answer is nothing but 1. Any 3-digit number written even number of times. Any 3-digit number written even number of times, it is always divisible by 1001. This is the first concept. This is the first concept. Second, one more line we will write. I am not interested in just solving the problem. I am interested in making students learn the divisibility rule of 1001. Learn the divisibility rule of 1001. Second conclusion. Any single non-zero digit, any single non-zero digit written in groups of 6, any single non-zero digit written in groups of 6, is always divisible by 1001. 7, 11, 13, 77, 91, 143 and 1001. Any single, next key point, any single non-zero digit, the way I am explaining in the class is the way that you should write down in your notebook. Any single non-zero digit written in groups of 6, any single non-zero digit written in groups of 6, it is always divisible by 1001. Example. 2 is written 6 times. 2 is written 6 times divided by 1001. 2 is written 6 times divided by 1001. Take a group of 3 plus minus. 222 minus 222. It is 0. Groups of 6 is nothing but a triplet taken twice. A triplet taken twice is nothing but a 3-digit number written 2 times. 3-digit number written 2 times. Suppose if the question is 5, 5, 5, 5, 5, 5, 5, 5 divided by 1001. 5, 5, 5, 5, 555, 555, 5 divided by 1001. Take a group of 3 digits. Take a group of 3 digits. These both will get cancelled. What is remaining? 5. What is remaining? 5. What is remaining? 5. I hope this concept is clear. Again, I am repeating. 2002, it is a composite number. 2002 is 2 into 1001. 1001 can be written as 7 into 11 into 13. 10 cube divided by 1001 is minus 1. From 1001, I took 7, 11, 13 factors. Any 3-digit number written even number of times is always divisible by 7, 11, 13. Any single non-zero digit written in groups of 6 is always divisible by 1001. Is always divisible by 1001. I hope this concept is clear. Now we will solve this problem. Every question which I take in the class should add a lot of value to the students. 2 into 1001. 2 into 1001. Question is nothing but 6 divided by 2 into 1001. 2 into 1001. 2 into 1001. Now see here. 2 unit digit is divisible by 2. So it is 2a. It is 2a. 6 is written 2002 times. Let me write down 6 times. Plus minus, it is 0. If 6 is written 6 times, it is divisible by 1001. If 6 is written 6 times, it is divisible by 1001. So 2002 is 6 into 6 3s are 18, 20. 6 3s are 18, 20. 333 plus 4. So 333 groups are there. 333 groups of 6 are there. Remaining how many 6 are left? How many 6 are left? 4 6 are left. I hope it is clear. 2002 is 6 into 333 plus 4. 333 groups are there of 6. So any single non-zero digit written in groups of 6, it is perfectly divisible. Remaining it is 4 divided by 1001. So take a group of 3 digits. 666 minus 60. Answer for this question is 660. Beautiful question which explains the, let us see, 111. 111 is nothing but 37 into 3. So these are nothing but remainder 1. 17 power 36 plus 19 power 36 divided by 37. Divided by 37. These 1 and it is also 1. 1 plus 1, it is nothing but 2. It is nothing but 2. So 1 when divided by 37, remainder it is 2. Similarly, remainder 1, 17 power 36 plus 19 power 36 divided by 3. 3 6 are 18 minus 1 power even plus 1. So it is 2. So it is 3b plus 2. 37a plus 2 equivalent to 3b plus 2. A is 0 and b is 0. So answer for this question is 2. Answer for this question is 2. I hope the idea it is clear. Only the class is based on a Chinese remainder theorem. Chinese